Hey there, this is Robert Kornacki, board member of the Ergo Foundation and head of research at Ergo. Today marks a really exciting moment because now that we are almost a year, near a year and a half in to the release of Ergo, we've got a lot of really solid tech laid out. And now we're really focused from the Ergo Foundation perspective to make sure that the end user experience is addressed so that everyone can really enjoy the tech and not just read the code, read the papers, have to use, a complex command line application, but instead we're actually allowing end users to get a lot more quickly bootstrapped into the ecosystem. And as you may know, that's why we're releasing Yoroi, and we've done this partnership with Ergo. And so that's on the wallet end. And that's something that's very exciting, and we know that's going to grow into something very big with eventually smart contract support and having a really awesome end-to-end user experience for using the Ergo network itself for end users. For developers, we have a lot of great tools and we've made a lot of amazing advancements. However, a lot of the work done is scattered across different repos. It's hard to find. Jumping into developing smart contracts isn't actually that hard because we have good tooling, but we haven't really made it accessible for people. And now that we're addressing the end user experience with Yoroi, and maybe other wallets that'll be coming in the future too, which will try to have better UIs and be Ergo specific, we also now want to enable developers to jump right in and have an easy to go place that makes it blindingly obvious how they can start writing smart contracts and have great examples so that they can learn. Ergoscript is actually quite a simple language to jump into. And while the extended UTXO model is slightly unique and takes some adopting your mindset to get used to, because you don't just have a bunch of functions that execute kind of like an account-based or imperative model, but instead you just have a script, and if it passes and if everything verifies, validates to true, then your smart contract works. And so what you have to do is reconfigure, reset how you expect things to work. But then that allows you to see that, in fact, a lot of contracts are much simpler to write in Ergoscript, even though you still have all this power, especially across transactions, where, in my opinion, we have even new capabilities that were never before possible in account-based models. So, what I'm here to show you today is that today we are releasing Ergoscript by example. This is a repository that is on GitHub, and this will be our first step to really help onboard developers into the Ergo ecosystem that we're doing now in Q4 of 2020 and moving forward into 2021 as well. So, Ergoscript by example is a repo that is similar to other programming languages you may have seen, which have like Rust by example, or JavaScript by example, and so on and forth. These are websites, repos, which teach you how to use the programming language at hand via easy to use examples that the user can latch onto and read for themselves, test for themselves. And so this is an opportune location for someone who wants to get started in developing Ergo smart contracts to visit and read. In this video, we're going to now just jump into this repo because I think this is quite exciting, because what I'm also going to reveal in a pseudo release style in regard to improving the developer experience is not that we're releasing the Ergoscript by example repo by itself, but we're also publicly releasing the Ergo Playground. And the Ergo Playground is something that's similar to what you may know maybe from the Cardano ecosystem, the Plutus Playground. But this is much more developer focused with more of a text-based approach rather than a visual approach. We'll get into all of that right now, so let's jump right in. So, as you see in front of you, we have the Ergoscript by example repo. Effectively, this is an open repo where anyone can contribute. So after this video, if this seems exciting to you, feel free to read this part in the README and write some of your own contracts, contribute, and we can really get all of this moving forward as we have a lot of individual contributors throwing in their own Ergoscript by examples, and we can really start to develop an awesome repository of explanatory code. So for people who are interested rather than contributing but in learning, what you'll find here is that you can either go through the files up here, but much more easily, we're going to have a list of Ergoscript examples. And so right now, we currently have one example that is the Pinlock Contract. Over time, as people submit examples, this list will grow to 1, 2, 3, 4, 10, 100, 500, etc. And you'll be able to just click through on the titles here to go to the example. All of these examples have a reasonably strict format that they need to follow so that we can have a very clean experience for anyone who's trying to learn. So as you can see here, the title, Pinlock Contract. You have the author, which is me, the date when the example is created, the license, and a link to the Ergo Playground for this contract. We'll get into that right in a moment, but first, let's just finish what's on this page, and then I'll show you the really exciting part. So, we obviously have the description, and so I can summarize here. A Pinlock contract is a super simple smart contract that I've used in examples in other blockchains before, which simply takes users' input of a PIN number and a input of a box, a UTXO, of some amount of ergs. And then with the PIN number and the ergs, it then locks those ergs in a smart contract that requires the PIN number to unlock. So it's kind of like a super simple bank account with a PIN number on chain. And so if you have a PIN number of 1, 2, 3, 4, you need to provide 1, 2, 3, 4 in order to spend that UTXO. If we want to be a little bit more pedantic, since this is more developer focused, what we're doing here is that we take the user's input, 1, 2, 3, 4, we hash it, and then we post that on chain with the smart contract, and then when we unlock it, we only post the clear text, the actual 1, 2, 3, 4. Then we hash that on chain in the smart contract and then check for equality with the original hash that was provided. One last note is that for this given contract, this is not actually secure because when you post something in clear text to the mempool to be posted on chain, anyone else can read it. And so while this smart contract itself isn't something that should be actually used by people on mainnet, on chain, because bad actors can theoretically steal your funds. They can read your transaction with your withdrawal request, your withdrawal action. They can read that and then copy it and then beat you to it, front run you by submitting a higher transaction fee. In many cases, this is something that's kind of a common issue in a lot of very simple schemes in smart contracts. And so while front running is an issue, it's a bit more complex to solve. And so for beginner examples, we're not trying to make a 36-line smart contract. We're trying to go simple. And that's what this Pinlock contract is for. It's not meant to be a super secure contract you use on mainnet today, and it's going to be the best thing ever, and it's going to replace your bank account. but it's just a great introductory example for anyone to jump right in. And so as you've seen, we have all of these basic descriptive elements up here, the actual description of what the Pinlock contract is, and then we have the code. And so if you want, as you can see here, we have all the code actually on the GitHub page, and it's all in Scala syntax. However, we have the Ergo Playground, which makes this all so much better. So I click here to go to the Ergo Playground, and now we are in the Ergo Playground. What this is a entire development environment for writing Ergoscript and essentially Ergo smart contracts. This is super exciting because what this does is it takes Scasty, which is a Scala compiler, and it implements the Ergo Playground so that anytime you write any code here, it automatically generates a URL that you can share with anybody on Earth. This provides you a really interactive experience so that you can write some code, maybe you have an error, you can jump onto the Ergo Discord and ask us by submitting your URL of Scasty, of the Ergo Playground. And you can just send us a URL that actually links to your code that fails to compile. One of us can then read your code, see you made this error, fix it up for you, and then reply to your message with another URL with the fixed code. And in this code, we have a full Ergoscript smart contract compiled and an entire test scenario so that you can verify your contract works as expected. And that's why I'm really excited personally, because we have one developer from the Ergo core devs, Dennis, or you may know him as Green Hat, who has created the Ergo Playground a bit of a while ago. But this has been more on the down low. So I'm really excited today to be able to share this with you because I think this is by far the #1 way for anyone, even currently, to jump into writing extended UTXO based smart contracts today, and then also be able to move those smart contracts on chain. And so if you really want to be a smart contract dev, this is the tool to use today. So as I mentioned, this is the Pinlock contract from the the Ergoscript by example repo for the Pinlock contract. So this is the exact code that is required to run the contract in a test environment. And so what I'm going to do in this Ergo Playground is take you step by step in understanding how does this playground work, what can you do, and also how do we understand some of the basics of writing a smart contract so that you understand how this all works. So in the future, as more examples get posted, you yourself can jump right in, just read the comments and the descriptions, and you can already get a handle for playing around and testing and really understanding how these contracts and how the off-chain code for testing these contracts work in the Ergo Playground. So let's jump right in. As you can see here on top, we have a few imports. Some of these are for the compiler, for the playground itself. This is for creating a pay-to-script address. So if you would like to use a contract on chain, all you do is compile the pay-to-script address and you send funds to that address. And so on forth. We have a hashing function, etc., etc. So before we jump right in also, I would like to mention that Scasty again is essentially an online IDE or compiler for Scala. Ergoscript is Scala based, and so that's why we are in this environment. On the left here, you have some build settings. These aren't really important. Everything's already set up for you, so you don't even have to look at it. We have a few buttons here up top. All you really need to worry about is save, or you can do Control-Enter or Control-S to save. What save does is any code you've written, it saves it, obviously. It generates a new URL so that you can send it to someone else, and then it compiles your code and runs it. And so whenever you make any edits, click save, and you're good. From there, lastly, we have the console down here. When you click save, as you'll notice, it starts to compile, and then it produces all of the prints that are related to the code. And so when you're using the Ergo Playground, what you'll typically do is write code that performs an action with your smart contract, and then you'll print the results and read them here. For more experienced developers, in many ways, this is much more powerful than, let's say, visual components, because you can print specific things, you can have nonstop debugging, print messages so that you can really understand what's going on. However, for new developers, this may be a little bit more challenging compared to very GUI-based physical elements. So the Ergo Playground, while being a lot more user-friendly than other experiences for writing Ergo contracts, it is a little bit more intimidating because it is purely text-based. However, it is not that challenging, and we'll jump right in and you'll see why it really is quite simple for you to get started today. So the Pinlock contract, as I mentioned, requires submitting a pin and checking that pin against the hash. As you can read here, we have a Pinlock script, and the script is this one line. And what's actually really cool is that one line is our entire smart contract. Everything else here is the off-chain code to test the smart contract for the Ergo Playground. So our smart contract for the Pinlock contract states that our input index 0, so the very first input UTXO that we use in our transaction, this will be just a UTXO with the hashed pin number. So this will be the UTXO that locks our funds, that will have this script locking it. And in R4, it will have the hash of our pin. And so what we're saying here is that input 0 in our transaction, this hashed pin UTXO with our funds. In register 4, it has a collection of bytes. And so in other words, this is essentially a list of bytes. And we do not have the string type on chain in Ergoscript. And so instead we use a collection of bytes. And so going over again, in the first input, in input index 0, we look at R4, register 4, and we see that it has a collection of bytes, and we get the value inside of it. What this does is it gives us the value of the hashed pin number that is that's on chain in R4. Once we have that number, we check for equality. What do we check for equality with? What we check for equality is in the output index 0, so the first output in our transaction that we create, in register 4, we have another collection of bytes, which we get. But once we get that value, we then hash it with Blake 2B256. And that's what we check for equality with the original hash in R4 of the input. What does this mean? So when we submit funds into the Pinlock contract, at that same time, in R4 of that output UTXO, we put the hash of the pin number in R4. That's what this is. That means once we lock our funds, that UTXO exists on chain, and in R4, register 4, of that UTXO, we have the hash of the pin number as a collection of bytes, as a string, effectively. Once that's on chain, this contract locks that UTXO. And so in order to spend it, when a transaction tries to spend it, it looks that UTXO is the very first input, input 0, and it's checking for equality that the hashed pin in R4 as a collection of bytes is equal to the pin number that the user provided while creating this spending transaction. And so when the user creates this spending transaction, they create an output, that's the very first output at index 0, and in R4 of this output, they put a collection of bytes. And what this collection of bytes is the pin number, so let's say 1, 2, 3, 4, as a string, now as a collection of bytes. Once the user submits that, this smart contract, which is executed in the transaction, takes that value 1, 2, 3, 4, puts it through Blake2b256, which is a hashing function, and then it checks the equality of the original pin hash in the inputs, which is where our funds actually are, which are trying to get spent. And so in essence, we have the hashed pin on chain in R4 of our input 0 as a collection of bytes, which we then check against the output R4, which is a collection of bytes, but hashed. And so if the user provided a pin number 1, 2, 3, 4, and it hashes to the same hash that was on chain, then the two are equal, and the result of the smart contract is true, which means the transaction validates because it is a valid spending transaction. And that's how you write a basic smart contract for locking funds up in an extended UTXO model with a PIN number. It's one line, and it's not that complicated if you already have a little bit of experience with computer science for understanding types like a collection of bytes, plus understanding just a little bit about how UTXOs work. So that's quite exciting. And once you have this script, so essentially all you do is write your script like this, you put it in a variable, and then all you do is call Ergoscript compiler.compile, and you essentially compile your Pinlock script. Once we have this Pinlock contract, so the compiled script, and now we can start to use the Ergo Playground to test it. However, if you're interested, you can also use pay-to-script address here with your Pinlock contract like this, and then you can print the actual pay-to-script address of your contract. And so this is the address which, if you want to use a contract on chain, all you do is copy this, paste it in your ROI, your full node wallet, Coinbarn, whatever wallet you're using, and you can send funds to this contract. And so that is very exciting. However, as mentioned, this is a very insecure contract, and so I would not recommend using this on mainnet. And also, because this contract requires you to have some value in R4, it's typically advised not to just send funds to this unless you actually have a client which supports this smart contract. And so while you can lock this, lock any funds you wish under this smart contract, unless you have a dApp which supports this contract, it's not going to work properly. And so while it is very simple to send funds to a contract, obviously if you want to interact with the contract and the dApp, you need to actually have a full off-chain code which supports it. So this is all that you need if all you ever want to do is write an Ergoscript contract and compile it to use it on chain. However, the Ergo Playground provides you a full experience for writing and testing Ergoscript contracts. And that's what's really exciting here. And so quickly, we have the concept of scenarios and a simulated blockchain. So when testing optimally, we want to use a simulated blockchain or a mock chain, which we can just post to directly. So we can test our contracts without having to wait for blocks to be found, to have to go through all the problems of submitting transactions, dealing with networking, having an interface with a node, and so on forth. And so here we create a simulated blockchain we create what are called parties, which are actors or users who have a wallet attached to them. So in our case, we're creating a single user party. We're defining our PIN number here. So this is the user input. So if you want a different PIN number, change your PIN number here. We're creating a hashed PIN. So we're taking the hash of our PIN number. We're defining initial funds within our user party wallet. And then we're generating unspent boxes, unspent UTXOs for the user. And so this will be held in their wallet. And the amount of funds that will be held in these unspent boxes is the user funds we specified here. So this essentially prepares a test scenario for us to test our smart contract up here. Continuing forward, we're now depositing funds in our test scenario on this simulated blockchain. We're locking funds up with our PIN number. And so first, we're creating an output box that is locked under the smart contract and locked under a hashed PIN. And so we're locking half of our funds with the Pinlock Contract that we created up here. And in R4 of this output box, we are putting hashed PIN in that register. And so if you recall, hashed PIN is the PIN number the user provided, but with the Blake2B256 hash. This is all you need to do to create a simple box in the Ergoscript Playground, which makes this super powerful and easy to use. Always specifies the amount of funds we're putting in there, what script or contract that is going to be locking this UTXO, and any registers we need to fill. And in our case, that's R4 with hashed PIN. Once we have this UTXO, this box that we've created, we now need to actually post it onto the blockchain. And so how we do that is we create a transaction which creates this output box, output UTXO, as an output of the transaction. And so here we create a deposit transaction. So we create a transaction where the inputs are our unspent boxes, which we created at the start of our scenario here, generate unspent boxes, which are in the user party wallet. And so we are using the user party wallet to select unspent boxes that we created. Those are our inputs, which are going to be spent to create our Pinlock box output. And so this is the output. And so in the outputs of our transaction, we have this box as the only output. We specify a fee, which we can use min transaction fee, and then we specify that all change goes back into the user party wallet. With this, we've essentially created all of the logic that we need for depositing funds into our Pinlock contract. And so all you do is create an output box, create a transaction which actually generates the output box on the blockchain. Then once you have this deposit transaction, all you do is sign it. So you use the user party wallet to sign this transaction, and then we take the blockchain simulator, the simulated blockchain, and we send this deposited signed transaction. That is what you see here, is that we create a scenario, we create a user party, which has a wallet. We create the unspent UTXOs with that many nano ergs inside of them. Then we create the UTXO for the deposit transaction here, the Pinlock box. And here we sign this deposit transaction, and then we post or send this transaction to the simulated blockchain, which you can see right here, accepting transaction 43578 blah 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 to the blockchain. And so we have now deposited half of our funds, as we specified up here, to the blockchain. And so now we have, this amount divided by 2 minus minimum transaction fee. And so that leaves us with that amount. So as you see, we've created this test scenario of depositing funds into our locked contract using the Ergo Playground. And it's quite simple. All you do is specify an output box, a transaction, sign a transaction, and you post it to the simulated blockchain. From there, we're also going to create the withdraw scenario because our contract is two parts. You deposit funds into the contract and you withdraw funds from the contract when you provide a PIN. The withdraw transaction works essentially the same way. You create a withdraw box. This is a UTXO which goes back to the user's wallet, and here you specify that the amount that's going back is the amount you submitted minus a transaction fee. Here, the script, we're actually going to be specifying it's going back to the user's wallet. And so we take the user's wallet, we get the address, we take the pub key of the address, and we make that the script. In the register, we're actually going to be putting the PIN number. So 1, 2, 3, 4, for example, or whatever we put up above. And so if this PIN number matches the hash of the UTXO on chain, then that means this is the correct PIN number and the transaction will process. And so the contract will return true. Once we've created this withdraw box, then we create the withdraw transaction. Here we have our list of inputs, and our inputs are what we're trying to spend, right? And so what we're trying to spend in this scenario is our deposit box, our pinlock box, which holds the hash of the PIN number in R4 and our funds. So we use that as an input. And so since we have this deposit transaction signed from up above, we then use it and we call .output0 because we specified up here the pinlock box is our first output, right? Index 0. And so because we want to spend that box that we created on chain, we now reference that using deposit transaction sign .output0, and that is the input of our withdraw transaction so that we can spend the box to withdraw our funds. As our output, we have our withdraw box that we specified up here. This is just a UTXO that we create that goes back to the user's wallet. Once again, we specify the transaction fee and change goes back to the user's wallet. This is all the logic we needed because the only thing that we had to do was supply the PIN number as a collection of bytes, which is what the get bytes are for, inside of R4. So this is the clear text PIN number, which is in output 0, and then the smart contract of our pinlock contract, which is locking our input 0 in this right here. That's checking that in the R4 of this input 0, which is the hash PIN number, is equal to the hash of R4 of our output 0. And so that's our PIN number that we submitted in clear text. And so since we've created this, this matches the smart contract logic. And so now that we have a valid withdraw transaction, which we created right here, all we do is sign it with the user's wallet, and then we send it to the blockchain. And so as you can see here, once we have created this transaction, this is the withdraw transaction down here, the user's wallet signs it, and then the simulated blockchain accepts the transaction and the user withdraws this UTXO into their wallet. And so as you can see, at the end, the user's wallet holds this number of ergs. I think that's 980 million approximately. And so what this means is that we originally had this amount. We deposited funds into the Pinlock contract, which had a transaction fee, which you can see here. So it's not 500 million, but 490 million. And then we withdrew the 500 million from the Pinlock contract, which we submitted, but because we had to pay another transaction fee, then we had another 10 million removed, and so we end up with 980 million. So it's 20 less than this because we had to pay 10 million each time for the transaction fee. And just so you know, these are 10 million nano ergs and not ergs, and so this is a very, very small amount of money for the transaction fee. And so as you can see, we have created a very simple one-line smart contract, the Pinlock contract, and an entire test scenario for verifying that our contract works. Just going quickly over here, up here we got the pay to script address, which you can see here in the terminal. We created a test scenario with a simulated blockchain, with a single user, with a PIN number, which we created a deposit transaction, which locks the user's funds under that PIN number. And then we created a withdraw transaction, which withdraws that user's funds from the Pinlock contract down here. And so as you can see with the Ergo Playground, we have this full-fledged encompassed environment for any developer to jump right in to start writing Ergoscript contracts and entire test scenarios so that they themselves can understand what's going on, but also to debug their contracts. Though we may be lacking a GUI or a visual aspect to creating these test scenarios, because they're in code, we have a lot more expressibility. And so you can create very complex test scenarios and be able to test maybe locking 25 different boxes with the Pinlock contract, each with a different pin, and testing different scenarios where you have 3 or 4 parties who keep trying to spend with improper PIN numbers, for example. You can test all of these things within the Ergo Playground and so much more, which makes it very powerful because, as you may have seen, it's really simple. It's really easy. It's the easiest to date method of creating and testing extended UTXO based smart contracts that we have in the world today. And that's why I'm really excited to show this off to you, because the Ergo Playground is very powerful, yet it's very simple to use. And so as a test environment for anyone who wants to jump right in to writing Ergo smart contracts, this is the place to go to get started. With that said, we've kind of gone deep into the Ergo Playground, and that's an awesome place, I guess, to finish off with. The Ergoscript by example repo has a bunch of examples up and coming, which will be just like this Pinlock contract. They'll all have pretty detailed comments talking about every single step of the way, so you know what's going on in the code. You'll have your contract and an explanation of how your contract works, and then you'll have a test scenario where this contract that is created in Ergoscript is then used with simulated off-chain code, with a simulated blockchain, and so you can read both the on-chain contract, the Ergoscript, and the off-chain simulated logic to see how the smart contract works, so you can get a real grasp of how does both off-chain and on-chain smart contract development work for extended UTXO based systems as a whole, but specifically for Ergo. So if you are a developer, I highly recommend that you jump right on in for this. You can just go to these SKSD links via the repo that we have created for Ergoscript by example, and you can have everything available to you. Just a quick reminder, when you go into an example in the repo, you can find the Ergo Playground link either up here on top or by the code. You can just click right there and you will directly go to the SCST website. You can even edit some of the code and then save it and copy the URL and share it with your friends. The power, simplicity, and the ability to share your code with the Ergo Playground is unmatched from anything that I've seen currently in any similar ecosystems that allow new users to jump right into writing smart contract code, testing, sharing with friends, and actually creating this whole environment of building on top of each other for smart contracts. This is a really exciting moment because now, as the Ergo Foundation, we're really focused on providing a better experience both for new end users but also for new developers to jump on into the ecosystem. And this Ergoscript by Example repo is our very first public announcement and release together with the Ergo Playground, so that we can really start to move forward into building a smart contract ecosystem and a blockchain as a whole that will only continue to snowball and grow as we continue to discover the new, greatest, latest smart contract and dApp technology that's never been possible before in old systems, while creating a whole onboard pathway for new developers to jump on in to understand what's going on. And this Ergoscript by Example repo, which will be updated on a weekly or bi-weekly basis by the core devs and current existing members, but potentially will grow into a fully community-owned repository where users will create some of their own test smart contracts to understand Ergoscript by themselves, and then create examples which will submit as PRs to this repo, and we'll start to have this very grassroots movement as we begin to understand this whole new sphere of extended UTXO based smart contracts on top of Ergo, step by step by step, while creating this treasure trove of examples and mini tutorials in effect, which people can just find here, jump right into, read the description to understand, and jump right into the code online in the Ergo Playground so that they can test and run for themselves. I think this is extremely exciting for us to get a lot of new developers. And so even if you don't have a lot of experience with programming, with Scala, or even with UTXO-based blockchains, the examples in this repo are meant to be super simple, super illustrative, and be very well documented. So if you're interested and excited about the future of UTXO-based blockchains, smart contracts, dApps, and everything around this, I believe that today is the day to get started. Jump right over to this repo and start reading the examples. And maybe if you're a great developer who's also really excited and wants to contribute, then please contribute examples yourself so that we can really start to create something special. Thank you so much for your time. This is Robert Kornacki, and have an awesome day.